We are Group 11. Our project title is Smart Office. I'm Man Choi, a Year 3 student studying computer engineering.
Hi, I'm Lan He, a Year 3 student studying in electrical engineering.
I'm Chen Wing He, a Year 3 student studying in computer engineering.
Hi, I'm Lion Heng Henry, a Year 3 student majoring in computer engineering.
Our project theme is Smart Office. The reason why we want to work on a smart office in this project is that, one day, while we are working in a lab inside Chao Yeching building, one of us suddenly got a call of nature and needs to be excused. In the process of finding a free toilet stall, we realized that some toilets in closer to CB103 are packed with people, while those that are further away are quite empty. Then we start to think how we can use IoT to help people find the nearest available toilet. We also want to give people a more pleasant experience inside toilet, as emptying the toilet will use extra energy. We thought that the smart office system should use renewable power to compensate the power consumed by the extra electronics installed. The project is divided into 4 units, and below is the architecture of overall system. We have installed solar panels to collect solar energy. Harvested energy will then be used to power our system. The smart toilet system aims to improve current toilet design, while the smart cubicle system aims to reduce energy consumption in office after working hour. Once a person entered the stall, it will be detected and the Arduino will consider the stall occupied. It will open the toilet lid and notify the STM32F4 board. After the person exited the toilet stall, the Arduino will close the toilet lid, and start flushing the toilet and sterilize the toilet seat before the next person entered. The Arduino Mega is connected to VL53LOX distance sensors, servo motor UV LED and a buzzer. VL53LOX measures the distance in front of the toilet seat and send data back to Arduino by I2C, so that the Arduino can determine the vacancy of toilet stalls. The servo motor controls the position of the toilet lid. The UV LED is used to sterilize the toilet seat. A buzzer is used to mimic the flushing sound of the toilet. The STM32F4 gets the vacancy of stalls from Arduino from UART AILI9341. A TFT LCD driver is connected with the STM32F4 with SPI protocol. The STM32F4 will show the status of each toilet stall in real time, to let other people know the usage of the toilet when all stalls are occupied. The LCD will show suggestions of toilets on other floors. We also implemented a smart cubicle lighting system for offices. We have designed a printed circuit board to construct the system. In this PCB, we have a upper layer consisting of STM32F1, and a lower layer which contains 12 connected for our auto lighting module. In the lower layer, it could supply 5 volts of 24 volts, depending on the load. The STM32F1 could drive it with a N MOSFET acting as a low side driver. For the input part, the lower layer has optocouplers to isolate the STM32F1 from the input side, so that input side could use sensors with different voltage level without damaging the STM32F1. As our auto lighting module outputs 5 volts for the PCB, a maximum 12 of auto lighting module could be connected to the system. This modular design enables varying amount of auto lighting module be installed for offices with different size. In a auto lighting module, it contains a infrared light transmitter, a infrared light receiver and a LED. The infrared transmitter and receiving is used to detect if anyone is sitting on the seat or not. If there is someone on the seat, the infrared emitted will be reflected, and the receiver will detect the reflected infrared light and generate a voltage level inversely proportional to T reflected light intensity. When the intensity exceeds the threshold, The STM32F1 will receive a low signal. The STM32 will then charge the gate of AN MOSFET and it will turn on the LED. There's a monitoring system and mobile interface, which has two major components, a server and ESP8266 node MCU. The server hosts a Telegram bot and present information for users, such as the vacancy of toilets on different floors, and statistics of toilets and office light. The reason why we use a bot API by Telegram is that it has cross-platform compatibility, as Apple and Android phones can use the same plugin. ESP8266 node MCU connects with Arduino Mega and LCD monitor in smart toilet system, and PCB in smart cubicle system, and collect information including occupation of toilet stalls and cubicle. Several solar panels is installed at the roof to collect solar power. We connected several of them in series and parallel to increase the total power aggregated by the solar panel. The energy will flow through a boost converter that increase the voltage to 5 volts, which is used to charge up LiPo battery. A power management IC is installed to prevent overcharging discharge the LiPo. The LiPo is then used to power other system in this project. Another problem that we encounter is in the designing of PCB. Although we have done many calculations to make sure the components work as intended, sometimes wrong usage of the board will damage some components of the board. For example, the LM22679 integrated switch buck converter that provides the 5 volts get damaged when one of our teammates shorted 24 volts and 5 volts. We have to spend time repairing the board. Initially, we use breadboard for the prototype of the electronic circuits. However, we found that wires are bundled together when the system gets more and more complex, and it is hard to maintain and it gets really difficult to troubleshoot and repair. Therefore, we started to organize the wires by making shields and PCBs. For example, we adopted a custom shield for the toilet system to fix the problem. Also, we modularized different parts of the system and used flat cables to connect between each other. We also designed some PCBs to eliminate breadboard from our design. This solves the problem created from the bundle of wires.